Hey everyone and welcome. Today we're going to talk about a language that's making some huge waves in the world of machine learning, Julia. And the reason it's getting so much attention is that it was literally built to solve this one big, nagging problem that's been bugging developers for years. So let's get into it.
So, for what feels like forever, machine learning has been all about this tough choice. On one side, you've got these really friendly languages like Python. They're super intuitive to write, and the number of tools available is just massive. But the second you throw a giant dataset at it and need some serious number crunching speed, things can really start to slow down. Then, on the other side, you've got absolute beasts like C++. Blazing fast, no question. But let's be honest, prototyping in C++ can feel like building a ship in a bottle. It's complex, it's slow to get started, and this whole situation is what everyone calls the two-language problem.
Okay, but what if you didn't have to make that choice? What if that whole compromise was just unnecessary? What if you could actually get the easy breezy syntax of a high-level language, but with the raw horsepower of a low-level one?
And this is where Julia steps onto the scene. It was literally designed from the ground up with one single mission in mind, to be the best of both worlds, to finally put an end to that frustrating trade-off between how fast you can write your code and how fast that code actually runs.
So what is Julia, really? Well, at its heart, it's a high-level language that feels natural, a lot like Python. But here's the magic trick. It's built for speed. The secret sauce is something called a just-in-time or JIT compiler. This thing is amazing. It takes your easy-to-read code and translates it into lightning-fast machine instructions right when it's needed. The result? You get speeds that are right up there with languages like C++.
And look, this isn't just hype. As Dennis Hill puts it in his book, Julia for Machine Learning, the language really does elegantly bridge this gap. And that's the perfect way to say it. It's all about creating one single environment where you can prototype, experiment, and then deploy your high-performance app without ever having to switch languages.
All right, so to really see how this plays out in the real world, we're going to walk through the typical journey of a machine learning project. We'll start with getting the data into shape, then we'll actually teach the machine, and finally, we'll talk about how to fine-tune the model to get the best possible results.
Okay, first up, data wrangling. And let's be real, this is where so many projects get bogged down. It's the often unglamorous but absolutely essential work of taking raw, messy, chaotic data and turning it into polished, structured material that a machine can actually understand. And with huge data sets, this is where Julia's speed can be a total game changer.
You've probably heard this saying a million times, but it's true for a reason. Garbage in, garbage out. It honestly doesn't matter if you have the most brilliant, sophisticated algorithm in the world. If you feed it bad data, you're going to get bad results. It's as simple as that. Everything, and I mean everything, hinges on the quality of your input.
So think of this whole data wrangling thing like a chef doing their prep work before the big meal. First, you got to clean your ingredients, getting rid of errors, figuring out what to do with missing values. Then you transform them. Maybe you scale your numbers or reformat categories. And finally, the really creative part, feature engineering, where you cook up brand new insights from the data you already have. And in Julia, awesome libraries like Flux.jl make all these steps feel both intuitive and just incredibly fast.
All right, our data is clean, it's prepped, it's ready to go. Now for the fun part, teaching the machine. And there are really two fundamental ways a model can learn from all that great data we just prepared.
So you've got two main schools of thought here. First, there's supervised learning. Think of this like studying for a test with an answer key. Your data comes with labels. This email is spam, this one is not spam. The model's job is to figure out the patterns to correctly label new emails. Then you've got unsupervised learning. This is more like being handed a giant, unlabeled box of photos and being told, find interesting groups. There are no right answers given up front. The model has to discover hidden patterns all on its own. And Julia's ecosystem, with tools like Flux.jl, gives you a really powerful and flexible toolkit to build models for either style. Okay, so we have a model that's learned something, but is it any good? That brings us to our final and maybe most crucial stage, finding the sweet spot. This is all about striking that perfect, delicate balance between a model that's way too simple and one that's way, way too complex.
This all comes down to a fundamental concept, a constant tug-of-war, called the bias-variance trade-off. On one end, you have high bias, or underfitting. The model is just too simple. It's like trying to draw a straight line through a curvy set of dots. It just misses the point completely. On the other extreme, you have high variance, or overfitting. The model is so complex that it doesn't just learn the signal in your data, it memorizes the random noise too. This kind of model looks brilliant on the data it trained on, but it completely falls apart when it sees something new. The goal is to land right in that sweet spot in the middle.
So how in the world do we stay in that perfect middle ground? Well, one of our best tools for the job is regularization. The easiest way to think about it is like putting a leash on your model to keep it from getting too crazy. Basically, it's a clever technique that adds a penalty during training every time the model gets more complex. This discourages it from overfitting and gently guides it towards a simpler, more robust solution. And you can imagine this process takes a lot of trial and error, which is yet another place where Julia's speed is a lifesaver.
And that right there really brings us full circle. When you think about it, from wrestling with raw data to training the actual model to carefully tuning it with techniques like regularization, the whole process is this intense cycle of computation and iteration. The whole promise of Julia is to make this entire journey from start to finish feel faster, more efficient, and just more cohesive because you never have to leave the language.
Which kind of leaves us with a really exciting thought for the future. As these tools, like Julia, continue to get better and more powerful, you have to wonder, could building a really powerful AI model one day be as straightforward as, say, building a website is today? It's a pretty cool thing to think about. Thanks for joining me to break this all down.